Okay, filtering. So here we are. We have our spatial domain image of Kayvon, and here's his frequency transform, right? And what if we just chop off all the high frequencies? So, right, we have all this high frequency stuff. I don't know, what does it do? Let's just set it all to 0 and see what happens. So we take all these high frequencies, we set it to 0. Here's what happens to our image. And this is, by the way, it's called a low pass filter. So here's the term, low pass filter, because we kept the low frequencies, we passed the low frequencies, and we cut the high frequencies. So this could also be called a high cut filter, although we usually call it low pass filter. Everything else goes to 0. We get a blurry image out the other side. Well, what if we take some mid frequencies, right? So we'll take this stuff and we'll keep it, and we'll throw away the low frequencies, we'll throw away the high frequencies. So this is called a band pass filter. So you may have heard this. We pass the frequencies in a certain band and we set everything else to 0. Well, this gets this kind of thing, where we see something about the image, but we don't really see the original image, but we kind of have some edges. Well, I don't know. Let's spread this out a little bit more. Let's take a higher frequency band. Well, now we see smaller little lines in here, but it's still somehow mostly along the edges in the image. Anyway, it looks like this. Or here's a high pass filter. So we've cut all the low frequencies and we take the high pass. Now we're left really with just the edges, right? So in fact, if you think of an edge detection filter in Photoshop or something like that, it was working essentially like this. They're doing something a little bit different, but it's essentially a high pass filter, and this is how we can find the edges in an image. All these things can sum up. There's a linear process that's going on. So we could add all these images up of all these frequencies, and we're going to get back to the original image.